Hey, music lovers, welcome. Have you ever hit play on a playlist and just thought, how did it know? Well, today we're pulling back the curtain on that feeling. We're going to dive into the incredible engineering that makes your favorite music app feel less like a computer program and more like, well, like magic.
I mean, seriously, think about it. You open up your Discover Weekly and somehow it's packed with all these amazing new artists you've never heard of, but you instantly love them. How on earth does it get your taste so right, sometimes even better than you do?
You know that little jolt of excitement when you find that perfect song? That's not an accident. That's not magic. It's the result of some of the most complex, massive-scale engineering happening on the entire planet. So let's break down how it actually works.
Okay, so before we get into the how, you got to understand why this is such a tough problem to solve in the first place. And the answer really comes down to one thing, just an absolutely mind-boggling scale.
Every single month, Spotify is serving 500 million, that's billion with a B, active listeners. To put that in perspective, that is a global audience bigger than the entire population of North America, all wanting their music to work perfectly right now.
And what are all those people listening to? Well, a library of over 100 million songs. Just think about the sheer amount of data that needs to be stored, sorted, and then delivered in a fraction of a second. It's wild.
And get this, on top of all that, we, the users, have created over 4 billion playlists. Every single one of those is another clue, another piece of the puzzle, another signal telling the system what music people love and what songs sound great together. So here's the bottom line. Getting flawless, buffer-free audio and hyper-personal recommendations to that many people with that much music, it's a monumental challenge. We're not just talking about playing a music file. We're talking about conducting this global symphony of data 24 hours a day. So how do they pull it off? Let's start with the most basic piece of this whole puzzle. How does a song travel from some server out in the world to your headphones, like the very instant you hit play? See, Spotify doesn't force you to download the whole 3-minute song before it starts. No way. The moment you tap that play button, it uses something called progressive streaming. It sends you the song in little pieces or chunks, always making sure you have the next few seconds ready to go right before you need them. And that's why it feels so instantaneous.
But wait, how do even those first little chunks arrive so fast? That's where something called a Content Delivery Network, or CDN, comes in. Just picture a huge worldwide web of computer servers, and they all have copies of the music stored on them. When you press play, your phone talks to the server that's physically closest to you. Less distance for the data to travel means, you guessed it, more speed. It's that simple. Proximity equals speed. I love this analogy. It just makes so much sense. Instead of you sitting there waiting for the whole song to download, which is like waiting for the entire 3-course meal to be cooked, the waiter, or the CDN, brings you the first part right away. You get to start enjoying your music immediately while the rest of it is being served up in the background. Okay, so the song gets to our ears instantly. That's cool. But how did Spotify even know we wanted to hear that specific song to begin with? Now let's get into the real magic, the brain behind it all, the recommendation engine. The very first layer is a fascinating idea called collaborative filtering. So just imagine, somewhere out there in the world, there's another Spotify user who has almost the exact same listening history as you. They are your musical twin. Now, if your twin discovers a brand new song and puts it on repeat, the system flags that. It predicts, with some pretty scary accuracy, that you're probably going to love it too.
So the second layer is basically like teaching the computer how to read the entire internet. It uses natural language processing to scan millions of web pages, music blogs, song reviews, articles, and it analyzes the words people are using to describe the music. So if tons of people are describing two different bands using words like dreamy or synth-heavy or melancholic, the algorithm learns, hey, these two probably have a similar vibe.
And finally, we get to the third layer. And this is where the machine actually listens to the music. I'm not kidding. Machine learning models analyze the raw audio file of every single song in the library. They break it down into cold, hard data points like its tempo, its energy, its key, even a metric they call danceability. It essentially creates a unique audio fingerprint for every track. So think about it. You've got what your musical twin likes, what the internet thinks a song feels like, and what the song actually sounds like based on its audio fingerprint. Spotify's system takes these three super powerful signals, throws them all together, and that incredible alchemy is what creates your totally unique, one-of-a-kind Discover Weekly playlist every single Monday.
Now, that recommendation engine is incredible, but it doesn't mean a thing if the app is always crashing, right? So how does Spotify manage to stay up and running for 500 million of us, especially during those huge can't-miss moments in music?
The secret sauce here is an architecture called microservices. So, instead of being one giant, clunky application, that's called a monolith, where if one little thing breaks, the whole thing comes crashing down, Spotify's actually built out of hundreds of tiny independent services. There's one for search, one for your playlists, one for the play button. It means that if some bug pops up in the podcast part of the app, it has absolutely no effect on your music. Everything else just keeps on chugging along.
And what about those moments when everyone rushes to the app at once? Like when a new Taylor Swift album drops. For that, they use something called autoscaling. The system literally detects that massive surge in traffic and in real time automatically spins up more server power to handle the load. Then, when things come down, it scales back. It's like the whole system can breathe, expanding and contracting to meet the exact demand of the moment.
So there you have it. We went from that feeling of pure magic all the way down to the nuts and bolts of the engineering. The scale, the streaming, the recommendations. The next time you hit play and that perfect song comes on, maybe you'll hear it a little differently. So I guess my last question for you is, now that you've seen the code behind the chorus, does it change how the music feels? Does knowing the logic behind the magic actually make you appreciate it even more?